Hello. Today we're going to talk about derivation of capacitance formula. So capacitance in Chinese is 电容. Okay. All right. So when you think about capacitance, you think about two parallel plates. And say you have positive charge there and negative charge there. And then you apply a battery across that. So this is positive, negative, and has the voltage. The battery has the voltage of V. And so from before, the E, right, from the Gauss law, and then later we have the unit charge density per area, right, is equal to this, right, divided by epsilon 0. And this one here was defined as sigma, and that's epsilon 0. And this is called the unit, right, unit charge, right, surface, unit surface charge density. Okay, and that's Q divided by A. So this is Q, and that's also Q, right? So this is positive, negative, and the area of this plate is A. Okay, so you can calculate this Q divided by A. Okay, based on the area and the charge that's on the plate. And epsilon 0 is the permittivity of free space. So free space here is the air or the vacuum, right? So this is the air right now. That's air. And that's equal to 9 times 10 to negative 12, I believe. Yeah, negative 12. And then the unit is C squared, the Newton meter squared. Okay. All right. So how are we going to go from here? So remember the V, right? And the V, it's equal to E times D. Okay. So we know this is V, and the electric field that's between these two parallel plates is E. Okay, and it's constant, right? But around the edge will be a little different according to the scientist. It's going to look like that. Okay, but normally we just deal with this in the middle. Okay, and so this formula is useful for us to start. And so this is equal to, we can put this one into here. So then that's equal to Q divided by A epsilon 0 times D. Okay. All right. So then we're going to move things around a little bit, and we're going to have epsilon 0. So we're going to move it to here, right? So this is V1. So epsilon 0, A divided by D. And this D is this distance here. Okay. So epsilon 0 is going to come to this side, and then V is going to come to the other side. So that's equal to epsilon 0 A divided by D, right? So that must be Q divided by V, okay? And Q divided by V, the scientists define this one as the capacitance, right? So C is the new variable, and it's going to be called, C is called capacitance. Okay? And that's in unit of farad, okay? F, so F-A-R-A-D, right? So farad, okay? All right? So what we have just done is basically C, it's equal to epsilon 0 A divided by D. So this is the formula for a capacitance. And you can see it's depending on this epsilon 0 here. So if we put different material in between the parallel plate, this is not going to be epsilon 0 anymore. It's going to become epsilon, and that would change. Okay, so when you put different dielectrics, 电介质 into the middle, then you will see that this epsilon 0 is not the same. So your C will not be the same. So C is depends on the material in between the parallel plates and the area here of the parallel plate, and the spacing between the plates. So this is geometric here, and that's the material between the parallel plates. The other thing that we get, okay, we're gonna erase this, is that Q is equal to CV. So what it says is, given a C, right? If you're given a D here and given an A there, okay, when you put an external battery on it, V, then this Q that will be on here on the parallel plate. So how much of the Q that you have is depend on the V. So the larger the V, the larger the Q, given the C is constant, right? So if we say this is constant right now, so we don't change the material in between here, right? So this is just air right now. So then Q is proportional to the V, right? So putting larger V would actually have more charges here. So let's continue. So when you have a V here, this charge is not from the battery. It's actually the electrons here that's on the metal, this parallel plates. So you have electron here, you have electron here, electron here. So this electron is moving, it's being attracted by this positive sign. And so the electron is moving this way and then come over and then get expelled by this and then come deposit on here. So then this negative Q is coming from this electron moving from the left-hand side coming over to this side. So now you have an extra electron here, okay? And this side here, you're basically losing electrons. So this is gone, this is gone, this is gone. So now it becomes positive. So that's how you charging a parallel plates, two parallel plates. Okay, so to summarize, one, what we find is C is related to epsilon 0 times the A. So the larger the A, the larger the C. And the smaller the D, the larger the C. Okay, so C is proportional to A, and then C is proportional to 1 over D. Okay, but epsilon 0, this later can be epsilon, and we'll talk about that later. All right, and 2 is that Q is equal to CV. So given the C, right, given this, the D is given, A is given, and then the material in between here is the air. So air then is epsilon 0, because this is permittivity of free space, right? So then given that, then the larger this V here, the larger the Q, okay? So then Q will be proportional to V, all right? And for the capacitance, the symbol is this. So equals, equal length, right? So this is capacitance symbol. For the battery, the symbol is like that. So this is for the battery. Okay? And the longer one is positive and the short one is negative. All right, so that's all we have for today. Yeah. See you later. Bye-bye.